Hello friends, Mr. Burrell here. We're in Unit 3. We're talking about polynomial functions, and we're going to take a little bit, not really a detour, but we're going to talk a little bit about complex operations. Because when we talk about complex numbers, we deal with them and we work with them in a very similar way as we do to polynomial functions and polynomial expressions. So a lot of the concepts that we discuss right now are going to be very similar to the concepts we talked about in the 3.1 video, and again in relation to concepts we've already learned in Math 2. This is another kind of review concept that we'll add on, tick on a few extra things as we go along. So why do we learn about operations with complex numbers? Complex and imaginary numbers are used by electrical engineers, in cellular and other wireless technologies, radar, quantum physics. We will use it later in Math 3. And beyond. You'll use it beyond and above that too if you ever do any mathematics beyond this, etc., etc., etc. We do see complex numbers a lot, so that's why we're covering them right now. So objectives, by the end of this video, by the end of this lesson, this is what I hope that you're able to do. I hope that you know that I squared is equal to -1. If you forgot what that means, we'll discuss it. I want us to be able to add and subtract complex numbers and multiply complex numbers. And at the end of this video, I'll go over a couple extra challenge objectives, but we'll get to those when we get to those. So, some definitions for you to remember. An imaginary number is a number that is expressed in terms of the square root of a negative number, usually the square root of -1 represented by I. So if you remember from Math 2 in some of your past experience, when I square root a negative number, I can't do it in the real number line. I can take like the square root of a positive 1. The square root of positive 1 would be 1. The square root of a positive 4 would be 2, because 2 times 2 is 4. 1 times 1 is 1. The square root of 9 is 3, because 3 times 3 is 9. But the square root of -1, there's not a number if I multiply by itself that will give me -1, so I classify that as an imaginary number, and I use the letter I to denote that. So whenever I square root a negative number, I get an imaginary number, and I denote that with the letter I. So the only difference between an imaginary number and a complex number, a lot of times people not confuse the two, but relate the two really closely because they are very similar. A complex number is just a combination of a real and an imaginary number in this form, a plus bi. So 3 plus 2i, 4 minus 7i, 1 plus I. Whenever I take a real number and add an imaginary number, or a real number and subtract an imaginary number, that's a complex number. A real and an imaginary number added or subtracted together. So again, in this situation, a is the real number, bi, any number multiplied by I, is the imaginary number. So this is a term that you probably haven't heard before, the complex conjugate. The complex conjugate is the number with an equal real part and imaginary part, equal in magnitude but opposite in sign. Blah, 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 blah. That's a lot of words there. But basically what a conjugate is, when I'm talking about a complex conjugate, if I have a number a plus bi, its conjugate is going to be a minus bi. They're like opposites of each other. If I have a complex number a minus bi, the conjugate would be a plus bi. So in this case, the conjugate of 3 plus 2i is 3 minus 2i. The conjugate of 4 minus 7i is 4 plus 7i. The conjugate of 1 plus I is 1 minus I. So the conjugate just flips that sign from positive to negative, or from negative to positive. And here again is kind of a view of what a complex number is made up of, with the reminder that I squared is equal to -1, because I is equal to the square root of -1. And I'll talk about that a little bit more on the coming pages. So, we just discussed on the previous page, when I square root a negative number, I get an imaginary number, I. So if I were to go ahead and square both sides of this equal sign, because I can do that, I can square both sides of an equation, a square and a square root cancel each other out, and I'm left with I squared equals -1. So right here, I squared is equal to -1. So we talked about the concept that when I square root a negative number, I get an imaginary number. Conversely, when I square an imaginary number, I get a negative number. I squared is equal to -1. I is equal to the square root of negative 1. So that's going to come in handy when we start talking about adding, subtracting, and multiplying, especially complex numbers. So let's do some examples. Let's simplify these expressions. For these addition and subtraction problems, you can treat these i's just as if they were regular variables, like an x, or a y, or a z. So for example, in this problem, I have 7 plus 5i plus negative 2 plus 8i. So I'm going to go ahead and combine all my like terms. I'm going to add them together. 7 plus negative 2, those are both like terms. They're both numbers, real numbers, so I can combine them together. 7 plus negative 2, or 7 minus 2, is 5. And then I have these these imaginary numbers. The imaginary part of these complex numbers, I can combine them together because they're both imaginary. So 5i plus 8i is a positive 13i. So my simplified answer is 5 plus 13i. Again, this is very, very similar to the last section when we talked about adding and subtracting polynomials, except now instead of x's and y's, I have i's. I treat them the exact same way. Now here, when I have 1 minus 5i minus 4 minus 7i, remember when I subtracted polynomials, that subtraction sign changed all of the signs in the polynomial that the subtraction sign was in front of. The same applies here. If I have a complex number that I am subtracting, this negative is going to change all of these signs here. When I distribute this negative in here, it turns into adding a negative 4 and a positive 7i. That negative will just change each of these signs, and it turns into an addition problem. So 1 plus negative 4 is negative 3. Negative 5i plus 7i is 2i. So my final simplified complex number there is negative 3 plus 2i. So adding and subtracting complex numbers is the exact same as adding and subtracting polynomials. No difference, except I just have an I instead of an x's and y's. Now we're going to go ahead and multiply some complex numbers. Again, multiplying is very, very similar to multiplying polynomials. We're just going to talk about a slight difference here. So here I have 3 times negative 7i times negative 7 minus 3i. There's 3 things here that I'm multiplying together. So first I'm going to multiply these two together. 3 times negative 7i is negative 21i. Boom. Love it. Okay. Now that I multiplied those two together, I can multiply this by negative 7 minus 3i. This part right here. So I'm going to go ahead and distribute negative 21i and multiply it by every part that is in this other parentheses. Every element of this parentheses, every term, I'm going to multiply by negative 21i. So negative 21 times negative 7, what is that? I don't even know off the top of my head. Negative 21 times negative 7 is going to be like 147. 147i. This I just comes along for the road here. For the ride, sorry. Negative 21i times negative 3i is going to be a positive. 21 times 3 is 63. I times I is I squared. And as of last lesson, as of the last video that we watched, I'd be done with polynomials. This is as far as I need to go. But the instructions here say simplify, and when I'm talking about complex numbers, I can simplify this even further because I squared is equal to negative 1. So 147i plus 63i squared is really the same as 147i plus 63 times negative 1. Well, 63 times negative 1 is negative 63. So my answer is 147i minus 63, or if you write complex numbers, we usually write complex numbers with the real portion first. It doesn't matter. So if I wrote it this way, it would be negative 63 plus 147i. In complex expressions, you should never have an I squared because you can technically simplify that to negative 1. Let's try another one. When I have two binomials here, remember when I'm distributing these two terms, these two polynomials, or sorry, complex numbers together, everything in the first parentheses needs to be multiplied by everything in the second parentheses. So I'm going to use the rainbow method here. 3 times negative 8, 3 times negative 7i, 3i times negative 8, 3i times negative 7i. I'm going to do each of those little multiplication problems and then write them all out added together. So 3 times negative 8 is negative 24. 3 times negative 7 is negative 21i. 3i times negative 8 is negative 24i. You'll notice that we can combine those together here in a second. And then 3i times negative 7i is negative 21i squared. So first, let's combine these two together. These are like terms. Negative 21i minus 24i is negative 45i. And I have this negative 21i squared. But remember, I squared is equal to negative 1. So this is really negative 21 times negative 1. Okay, so that's negative 24 minus 45i plus 21. Well, now these two can be combined together because they're like terms. Negative 24 plus 21 is negative 3. So my final answer is negative 3 minus 45i. Ah, love it. Every time you multiply complex numbers together, you should end up with a real portion and an imaginary portion and nothing else. If you end up with other terms out there, you haven't simplified it all the way yet. Okay. Let's see. Let's do 5 and 6 here. So here I have 4i times negative 4i times negative 3 minus 8i. So again, I have 3 terms here, so I'm going to start by just multiplying the first two. 4i times negative 4i is negative 16i squared. Before I do anything else, this I squared I can really write as negative 16 times negative 1, which is what? Negative 16 times negative 1 is a positive 16. So I've multiplied these two together. I got positive 16. Now I'm going to multiply that by negative 3 minus 8i. 16 times negative 3, well, that's negative 48. 16 times negative 8i, well, that's negative 128i. So my final answer is negative 48 minus 128i. Okay, number 6. This is an interesting question. I have negative 1 minus 8i squared. What does squared mean again when I square something? Well, 2 squared is equal to 2 multiplied by itself. So just 2 times 2. So negative 1 minus 8i squared is just negative 1 minus 8i multiplied by itself times negative 1 minus 8i. So this is going to turn into a very similar problem as on the previous slide, where I'm going to have to multiply everything in this first parentheses by everything in the second parentheses. This time, I'm going to use the box method for those who like the box method. Negative 1 minus 8i, negative 1 minus 8i, I'm going to multiply each respective row and column. So negative 1 times negative 1 is a positive 1. Negative 1 times negative 8i is a positive 8i. Negative 8i times negative 1 is a positive 8i. And negative 8i times negative 8i is positive 64i squared. So if I write out all these terms, I have 1 plus 8i plus 8i plus 64i squared. Well, these two terms can combine together because they're the same, 8i plus 8i. And note that 64i squared is really just 64 times negative 1. So I have 1 plus 16i minus 64. Well, now 1 and negative 64 are like terms, so I can combine them together. I get negative 63 plus 16i, which is my final answer. So that's multiplying complex numbers. The big thing to remember is that I squared is equal to negative 1. Whenever you see an I squared, that really just means that I'm multiplying by negative 1. Okay, I'm going to leave these on the screen here. If you want to try these out for a little bit of a challenge, go ahead and try those ones out. Those are a little bit more complex. I encourage you to try those ones. You can pause this and try those. And then after this, these concepts I cover are going to be additional challenge concepts. So please watch these concepts because they will be useful. But the big objectives that I wanted you to achieve have already been discussed. So, we're going to talk just real briefly about graphing complex numbers. When we talk about graphing, usually I have an x-axis and a y-axis. So I have like an x coordinate and a y coordinate, so say 2, 5, which means I'd go 2 in the x direction and 1, 2, 3, 4, 5 in the y direction. When I talk about graphing a complex number, it's very similar, except instead of an x and y axis, I graph the real number along this horizontal x-axis and my imaginary number along this vertical y-axis. So here it says graph the real part on the x-axis and the imaginary part on the y-axis with a single point. So if I have the complex number 2 plus 5i, which you notice what I did here, these are very similar. This is an xy coordinate, this is a real and an imaginary coordinate. So if I'm graphing this on the complex plane, I'm going to go 2 units in the real direction and 5 units in the imaginary direction. So on this complex plane, this point would be represented by 2 plus 5i. So that's how you graph a complex number. Last thing we want to discuss is talking about rationalizing the denominator. So you've probably remembered in the past, if you had like a number divided by a square root, really we don't like that very much. Mathematicians don't like seeing radicals or square roots in the denominator. It's just not very pleasing to the eye. So we do something called rationalizing the denominator. Rationalizing the denominator to get that square root out of the bottom. So in a problem like this, when we're rationalizing the denominator, it's a similar concept. I don't like seeing this I in the denominator. It's very unpleasing to the eye. I. So in order to get rid of it, we're going to rationalize the denominator, and we do that by multiplying the numerator and the denominator by I. So I have 3 minus 4i divided by 2i, and I'm going to multiply the top and the bottom by I. I can do that because that's technically not changing this fraction. This isn't changing anything because I divided by I just cancels out to be 1. Anything divided by itself is 1. So I can use that as a helpful tactic in order to get this I out of the denominator, and I'll show you how. So when I multiply I on the top and the bottom, I get 3 times I, which is 3i, negative 4i times I, which is negative 4i squared. On the bottom, I get 2i times I, which is 2i squared. Well, remember, I squared is equal to negative 1, so anytime I have an I squared, it can be replaced with multiplying by negative 1. So here I have 3i minus 4 times negative 1 divided by 2 times negative 1. Well, negative 4 times negative 1, that's a positive 4, so I have 3i plus 4. And on the bottom, 2 times negative 1 is negative 2, so I have 3i plus 4 over negative 2. Or if we're writing in our complex number normal way, I'll write the real number first, which is 4 plus 3i over negative 2. So that's called rationalizing the denominator. If I had an I in the denominator, in order to get it out of there, I multiply by I on the top and I on the bottom, so that I on the bottom, when I multiply it by another I, ends up turning into a negative number. And that's it. That is the end of this lesson. Again, these are the main things that I wanted you to get by the end of this lesson. I wanted you to know that I squared is equal to negative 1. I wanted you to know how to add and subtract complex numbers and how to multiply complex numbers. Again, some of those last sections, those last slides were kind of extra objectives. Some challenge objectives that I would like you to try to learn and understand, but you should feel pretty confident if you've got these 3. So that's all I've got. I hope that was helpful. Please let me know if you have any questions, and I hope that you enjoyed that as much as I did.